So here we go, video number 3 using SoundEasy Lab measurement system. So in the first two videos, I was kind of baffled at, let's see here, let me go to the right photo here. So in this photo, looks like I took 6 cycles here, but this is using my Realtek ALC 892 line-in input. And this line here is this top guy here is the impulse response, but this waveform here up top is the reference, meaning at the amplifier's output, and this line here is the microphone input to the either probably the line in right side. So this is the left, this is the right coming in on the line in on my Realtek, motherboard sound card. This waveform here is actually the sound coming out of the speaker. It travels a distance of 62.888 centimeters. And we're going to put a marker here which removes this time of flight, and then we get to plot the frequency response down here. So the problem came up before where this looks like crosstalk. I don't have any zoom on here, but you really have to adjust your levels to minimize the crosstalk between the left and right of your line in or mic input. And this sampling here was at 192K, so really high sampling rate. This really comes up because of the high sample rate, and you have to adjust your levels, including the balance, and play around with that. Now, the best that I could get, let me go to another photo here. This photo here is same sound card, but at 48K sampling here. And that's at 74 centimeters, we're picking up at the microphone input, the MLS signal coming out of the speaker, the test signal coming out of the speaker. This here is like a room reflection. This little guy, this little nick here is that, at t equals 0, you still can see some crosstalk between the input and between the reference and the input, I should say. Right, and this is the best that I can get it. I took a lot of time adjusting the balance and the left and the right, and I couldn't get the levels all the way up to here on these LED indicators, but this was the best that I can get. And you see the woofer starts to roll off. It's an bass reflex cabinet. It starts to roll off around, 50 hertz or so. It's pretty flat, going all the way up to 20K. I do not use a I'm now using this M50 Earthworks microphone, which is a 1/4-inch microphone, pretty much flat all the way across the entire audio band. And this is my test speaker on the test here. Let me blow this up. That's the speaker under test. So that's pretty much the setup. The nearest wall is my ceiling, which is about, I don't know, how much is 100 and, let's see here. I forget how many inches away it is, but that's the nearest wall. Inches or centimeters, take a pick. So yeah, that was the issue. I've always used discrete sound cards with SoundEasy. This is my first time actually using and you know, the internal Realtek, you know, whatever, you know, chip codec on with SoundEasy. So I was surprised to see this. So anyway, let's go back to the SoundEasy now itself and use my Audio Firewire 4. So I'm controlling the Firewire 4 using this 1394 IEEE, you know, aka Firewire cable here, which goes into the back of my Echo Audio 410. This output goes to the amplifier, and this is channel 1 here. Channel 1 is connected to the back of the amplifier, and this is my mic input here. This is an adapter from RCA to 1/4 inch coming in. I'm going to connect this guy. These two guys are going to have the same signal on the back of the amplifier, and we're going to plot out a flat frequency response, a flat phase response between the channel 1 and channel 2. So if your sound card, you know, your sound card may not have a Firewire port, it may be USB or whatever, you really need to check the SoundEasy website. You know, there's only certain sound cards that are supported. I mean, you may connect and see if they'll support some other sound cards, but it's the main reason why I have a laptop like this, you know. So we want to go in here, and if you go to File Preferences, select the analog in 1 and 2 for the input device, and select Playback 1 and 2 Audio Firewire for the output device. This is a 16-bit sound card, by the way. It's not 24-bit. We won't leave these two, the reference and the data channel, inverted. It seems to work that. The polarity comes out right that way. Come back to Easy Lab measurement system. So we're going to leave the MLS length at 131K, sampling rate 96. And if I come over here to my Audio Firewire setup, you can see I have these levels here. Sampling rate is 96, matches SoundEasy. And we got this set to stereo so we can get to, you know, each individual channel here. So we're going to take check whether our deltas between the reference and the input are, you know, straight. So we're going to take a measurement. Now you're going to hear, you know, the measurement signal. So yeah, we have reference level here, and the input side you can see is a little high. I'm going to turn that way down. I probably turned it up when I connected the mic. And here we have these two guys here, the input or the reference up top here and the input. These two are identical. Obviously the reference side is a lot stronger signal right now. I just turned it down. We're going to try to take a few more measurements. Why don't I do this? Put it on 32K and put it on auto. And I'm going to adjust the measurements as it's plotting. So what I'm going to try to do is adjust these levels here. Okay. That looks good enough. Let's clear this out. I plot, get in frequency response, the red line here is basically flat from 10 hertz to 48K, 47 and change K. And there's a green line here, which is the phase, which is also 0. So the deltas between our reference and our input look correct here. Now I'm going to disconnect the input side and connect the microphone up so we can take acoustical measurements. And I'm going to have to adjust the microphone level. I am using the M50 microphone with another sound card, which I'm using its preamplifier as a mic preamp. So let's turn this up a bit and clear that. Okay, you see we got a little blip here. That looks like the sound coming picked up by the microphone, but looks like I need to turn up the levels. And of course I had the levels way down, so I just turned them up. We're going to take another measurement. Okay, so we got better levels here, and I'm going to turn it up a little more. So that looks good enough to me. And looks like right here is where our microphone is picking up the sound being emitted from the speaker, which is at distance 0. And we got some what you would call the impulse response right here. So we're going to put our acoustical marker about right where we think the impulse response is going to begin. I don't know what that is. Some kind of All right, we're going to plot this. Right, so it looks like we're at a distance of 75 centimeters from the speaker. So I'm just going to move our line back. Replot this. So I would say here from the second plot, we got the phases smoother here, and we don't have too many wraparounds here. I'm going to clear this and plot it again. So yeah, this is a bass reflex. So it looks like at 50 hertz here we got the tuning of the woofer and the cabinet, I guess, to get a null here. But here's a frequency response going all the way out to 20K right here, and then starts to roll off here. This null, I believe, is from a phase plug on the tweeter, as I mentioned before in the other video. So, but now, what we're really concerned about, if I zoom in, if I say 8x zoom, right, this just looks like a lot of random noise here. We're not seeing a copy of the reference inside of the input, unlike the Realtek sound card. So we're going to set that to say 4x, and we're going to move our marker somewhere. I don't know where to put this marker. We're going to try a few locations, and this here is likely the ceiling reflection, the nearest wall. Sound emits out, and hits the ceiling, then comes back down and lands upon the mic. The mic shows her, and the echo coming out of the speaker. And we can scroll over more. You'll probably see some more echoes somewhere. Yeah, here's more wall and ceiling echoes here. And they're being dissipated as you go further out in distance. We're going to plot this. Yeah, so we need to go back the other direction. So I'm going to say that somewhere in here is where the sound arrives upon the microphone. We're going to plot that. And I'm just going to make some adjustments here. So I'm moving my marker back. You'll see the distance here change. I'm moving it back and forth to see if I can get a nice smooth phase across this flat, relatively flat response here. You should get a nice smooth phase response. It wraps around. If you pick your acoustical distance correctly here. Let me clear. And let me try one more to the right. I kind of like that one. So, so this was using 32K for the MLS. Let's go all the way out to 262K and repeat this. I'm going to right. So with that longer length, we got a better frequency resolution, and look, the noise here is a lot less, right? Because we took a longer length here to take our frequency response, and you can see now we do not have any crosstalk here between the channels. We're at 4x now. I can go to 16x, and this random thing here is typical noise, but it's very small compared to the signal itself, right? We could not get this good with using the Realtek sound card, built-in motherboard sound card, whether you have a laptop or a desktop. I have to say that using a discrete sound card is much better to get rid of the crosstalk here. So I'm going to clear this out and do our plot. And yeah, that's our frequency response right there. So looks like we start rolling off somewhere near, I don't know, 50, 60 hertz. This cabinet is vented, so in order to make the vent show up here, you need this is probably the vent here, bouncing all directions in the room. And as you can see, between each line, gradient line here going left to right is about 5 dB, so it's pretty flat. Considering it's in my dining room here. This is 20K down to 60. And I just want to remind you of, yeah, so that speaker there, right? This guy right here. That's what we're measuring. Using the discrete sound card, the Echo Audio Firewire 4. I know he supports M Audio and some of the Echo Audio sound cards, and the Lynx if you have a Lynx sound card. So I would definitely stick with the discrete sound card. I mean, I found the Realtek to be real convenient because you don't have to, drag along separate hardware. But no crosstalk here. Anyway,